Kia ora Year 11 and 12. This video is going to go over how we rearrange a formula to make something else the subject. So in this video, the ones I'm going to do are mainly revision of Year 11. There are two good exercises in Theta, exercise 1601 and 1602, and there's a good page of practice in the Walker book as well. So we're going to start with this one, where we're given y equals 3 times x minus 7. And I'm not going to write this down every time because it would take too long, but I want you to make x the subject of the formula. So our goal here is somehow to isolate x. There are a few different ways we can go in some cases, but here it's pretty obvious what to do first, which is to expand out the brackets. That gives us 3x minus 21 on the right hand side. Right, my ultimate goal is to end up with x equals blah blah blah. So I'm going to do this. Add 21 to both sides. Now I've got 3x. And so we'll divide both sides by 3. So at this stage I'm going to write x equals, I'll do that in my head. I've got x equals y plus 21, all divided by 3. So that's okay, but it's probably a bit nicer to write it as y over 3 plus 7. Okay, so I'm going to do 3 more examples on the next few slides. Try and do them before I do them, so just pause the video and see how far you can get. So this is the formula for the volume of a sphere. That's why it says S. Here I want you to try and make R the subject of the formula. Now often when people see the pi sitting in formulae like this, it freaks them out a bit. Pi is just a number, right? So just treat it as you would treat any other number. So we're going to do this quite slowly. We'll multiply through and get 3s equals 4 pi r cubed. Right, again, doing the same thing to both sides of the equation all the time. Now I'm going to divide through by 4 pi. That leaves me with r cubed. So to get r on its own, I need to take the cube root of both sides. So this is going to be my final answer here. Now we haven't looked at fractional powers yet, but you might be able to figure them out before we even do them. We have to do something to this r cubed expression that will make it into r. So what operation is going to do that? Well, it's going to be r to the power of something, and it's going to be r to the power of 1/3. So that might be for some of you the first time that you've seen fractional powers. We don't strictly need them here because we can just work with our familiar cube root notation. We'll come back to that in a few weeks in the second batch of algebra. Okay, a couple more examples. Here's the next example. We've got two fractions, one's got x in it and one's got y in it. We're trying to make x the subject here. So we need to isolate that term with x in it, and we're going to do that by adding 4y plus 5 over 7 to both sides. And now we'll get a common denominator here. 5 sevens are 35, so 35 plus 4y plus 5 over 7. So here I've got x plus 1 over 3 equals 40 plus 4y over 7. I could go through this really slowly, but I think most of you watching will be pretty confident by now with the idea that we're going to multiply both sides by 7 and multiply both sides by 3. So what that gives me is 7 times x plus 1 is equal to 3 times 40 plus 4y. Expanding that out, I get 7x plus 7 is 120 plus 12y. 7x equals 113 plus 12y. So I'm subtracting 7 from both sides. And lastly, I'm going to divide both sides by 7. I'll do that up here. So x is equal to 113 plus 12y over 7. Or I could write that as 113 over 7 plus 12y over 7. Right, on to the last example that I'm going to do. So in this case we want to make v the subject. Now, to save time in these videos, I'm not talking about context very much at all. We'll do that in class. but you'll recognise lots of these formulas hopefully from science. So here, if we want to make v the subject, we're going to write 1 over v is equal to 1 over f minus 1 over u before we start combining any denominators. So I'm going to have 1 over v is equal to, common denominator, we're going to have f times u, which gives us uf or fu, and then we cross multiply here. So what did I have to do to the f to get that denominator? I had to multiply by u. So it's u here, and what did I have to do here to get uf? I had to multiply by f, so it's u minus f. So if 1 over v is equal to that, then v over 1 is equal to uf over u minus f. Now if you don't like that, we can do that a little bit more slowly like this. We've got 1 over v here, so we can cross multiply and we get uf is equal to v times u minus f. So we could go directly that way, or we could go over here. And then if we divide through again, we get uf over u minus f is equal to v. That one I have taken from either the Theta or the Walker book. It's a really classic example. It was actually in a level 1 exam a few years back. So make sure that you're really comfortable with working with fractions. And now you should be ready to do the Theta exercises and practice in the Walker book. This is one of the most useful skills that you get in maths, and you will already have found times this year probably in physics where you've got to use this skill to change the subject of a formula. Thanks for watching.